Welcome to today's lesson on scientific notation. We are going to look at how to write numbers in scientific notation and in standard form. So basically how to convert back and forth between the two, and then how to multiply and divide numbers in scientific notation. So scientific notation is really just a shorthand that we use to represent really large numbers or really, really small numbers. And in order for something to be in technical scientific notation, it has to be a positive number expressed in the form of a times 10 to some power, where a is a number between 1 and 10. It can be equal to 1, right? And it has to be less than 10. So basically it has to be a single-digit number. And that's it. It's that simple. N is an integer. And once you have it in that form, it's in standard scientific notation form. Now, if you have a negative number, could you still put it in scientific notation? Absolutely. It just wouldn't be considered standard form, but it would still work completely fine. So something like this, to convert back and forth, think about where the decimal place is right now. The decimal place is right here, right? What we have to do to put it in scientific notation form is we have to go 5.3, right, times 10 to some power. So we have to move this so that there's only one decimal place, right? One digit in front of the decimal place. And we moved it 1, 2, 3, 4 times. So it's 10 to the fourth. Same thing with here. We've got to move it 1, 2, 3, 4 times. So it's 5.3 times 10, but this one's to the negative 4. Because the reason why this is a positive 4, even though we were moving the decimal in the negative direction, it's the idea that to get this number back to where it was, we've got to go from 5.3, 4 stops in the positive direction. Same thing here. To get from 5.3 back to where it was, we're going 4 jumps in the negative direction. You can also always remember that a positive exponent means you're going to have a big number, right, with trailing zeros, and a negative number means you're going to have a really small number with leading zeros. Okay, so write the numbers in scientific notation. The number of movie tickets sold in the United States for a recent year is estimated to be 1.5 billion. That obviously wasn't during COVID, but we would take this decimal, right, and jump it a bunch of times till it was sitting right here. So we're going to have 1.5 times 10. Well, how many jumps was that? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just that simple. The weight of a flea is approximately this. I don't know why we do a weight of a flea in pounds. It'd be much more obvious to do it in ounces or grams. But in any case, right, we want it to be right here so that we only have one non-zero digit to the left. And then that means we moved it 1, 2, 3, 4 times. So 6.6 times 10 to the negative 4. Negative 43, right? Technically we're not supposed to do negatives, but you could think of it as negative 4.3 times 10. It's kind of stupid, right? We only use scientific notation for really big and really small numbers. Neither of these are really big or really small, right? Because 8.2 is already kind of there. It's 8.2 times 10 to the 0, right? Because we don't move the decimal at all. This is technically 10 to the 1, but we never write anything as a 1. So these two examples are stupid, right? They're silly. We wouldn't do that. We wouldn't waste our time putting those into scientific notation. Okay, so how about taking scientific notation and going in the other direction, putting it back into a normal number? Well, that's easy. All we got to do is move the decimal point this many times in that direction. So you start with 1, 6, 7, right? And it goes 1, 2, and then it's got to go 22 more times, but it's not going in that direction. It's going in that direction. So I got to put it way over here. 1, 6, 7, right? The decimal started here. It hops once to this direction because that's negative. So it's got to go negative 23. Right? There's never 23 of them or 23 of them. And then that would be my answer. Same thing here. We start with 1, 5, 5, 2 to go from here to the end of it is 3 jumps, and then we have 11 left. I think that's 11. But you get the idea. That's how easy it is. You figure out how many jumps you got to get to the end of your number, and then subtract that from the power, and that gives you how many zeros you got to add on, either in the beginning or in the end. The last thing we're going to look at is multiplying and dividing by scientific notation. The nice thing about multiplying and dividing is that scientific notation is easy to do multiplication and division because it's already written as multiplication. This is literally 8.7 times 10 to the fourth, 2.5 times 10 to the negative 12. And if we remember anything about multiplication, it's that we can do it in any order. It's called commutative. We can commute things. We can rearrange their order. So we can think of this as 8.7 times 2.5 times 10 to the fourth times 10 to the negative 12. Now all you got to do is 8.7 times 2.5 in your calculators. 8.7 times 2.5. That gives you 21.75. 21.75. And then remember that when you have anytime you have the same base raised to 2 powers, remember we use the rule of exponents, and it's simply just that power plus that power, and we get 10 to the negative 8. Now, this is not in scientific notation form, right? The decimal needs to be here. So we need to move it one spot and make it 2.175. And because we moved it to the left, right, we made this thing smaller, we got to move this one bigger to counteract it. So we're moving it to the right by 1. Remember, on a number line, going from negative 8 to the right by 1 step goes to negative 7. So this would be our answer in proper scientific form. Now with this, same thing. We can just take this and divide it by this, and then take the tens and divide them. So 4.25 divided by 8.5 gives us 1/2, right? 0.5. And then times 10. Again, we got to remember the rules. It's the top power minus the bottom power. So it's 13 minus a negative 2, which becomes 13 plus 2, which becomes 15. Again, not in standard form. We need to move this decimal here, right? Which makes it bigger, right? It goes from half to 5.0. So we got to make this one smaller to even it out so that it stays the same. And that's everything I got for you for scientific notation.